I want to welcome you to my session. I'm Linda Gojak, President of the National Council of Teachers of Mathematics. I did try to get the flash mob to come back and do their thing this morning, but they're all off already doing other things today. So if you missed the opening session, be sure to check it out online because it was great fun last night. How many of you have been to a wonderful session already today? I need sunglasses up here. Excellent. And how many of you have been in the exhibit hall? I kind of call that the Toys for Us for teachers. And oftentimes, although my original position for 28 years was in the classroom, for the last 10 years I've been working with teachers through a local university, and when they say to me, where do you get all your ideas? I tell them in the exhibit hall at NCTM meetings. So if you haven't been there, make sure you do take time to visit the exhibit hall. Before I begin, I want to let you know that all of my slides will be downloaded onto the NCTM website. So if you're on the, what do they call that? The app, the conference app, there'll be the link to the, I'm not quite sure how to do that, so I'm going to let somebody else do that for me, but at the end of this session, they will all be downloaded, so you'll get all of the links and the specifics. So if you want to focus in on the big ideas, that would be awesome. So what I want to talk to you today are about 8 instructional practices to promote sense-making, reasoning, number sense in grades K through 8. For the last several years, I have been working with math coaches in our local school districts. I've been out of the classroom now for about 10 years, and I miss it terribly. I miss being with the kids. I'm not sure I miss all the other stuff, but I really miss being with the kids. So in my working with coaches, I get back into the classroom in a local school district. I've had the opportunity to work with 4 awesome elementary school teachers that have just grown enormously in their understanding and appreciation for what we're all about. And I think it's kept me grounded. So as I began to prepare the talk, because I had to submit the title a year ago, I realized that there's probably more than 8, but I tried to hone it in on the 8 that were the most important. And I want to begin by saying that all of these have all been supported by previous and current documents. The Agenda for Action, which I still go back to, from 1980, which I think mentioned 8 to 10 steps that had to be on the agenda to improve mathematics instruction in the United States. And I would say those are every bit as true today as they were in 1980. Principles and Standards for School Mathematics. How many of you are familiar with that document or have it at home on your bookshelves? If you don't, you can get an electronic version if you log into NCTM and register, if you're not a member. And I think you get a 60-day free access to the document. You can also go buy it. And after 60 days, log in as somebody else, and you can get another 60 days. I really believe that this document still portrays the vision of NCTM and is not at all misaligned with the Common Core. In fact, the Common Core was very much based on Principles and Standards for School Mathematics. It really has been my personal Bible for teaching mathematics, as well as the work we're doing with teachers. The other book over to the right, Adding It Up, was not an NCTM publication. It comes from the National Academy's Press, and it's available still through the National Academy's Press, NAPEDU. It was the first publication from National Academy's Press, which is actually part of the National Academies of Sciences, that focused on K-8 mathematics. And I paid $45 for the book. You can now download it. If you register, you can download it for free. At the bottom left, you see curriculum focal points. Again, one of the underpinnings of the Common Core documents, whether you are K-8 or 9-12, the book in the center there, focus on high school mathematics. That's a bit of a misnomer because the reasoning and sense making, when I read that book, it is true confessions, not confession. My background is in K-8. I'm not a high school teacher. I met my brick wall in mathematics in Algebra 1. It makes me passionate about teaching kids Algebra 1 well, because I was not taught Algebra 1 well, and it almost did me in. And I loved mathematics up until then. So I'm not a high school teacher. I don't want to be a high school teacher. You guys who teach high school can handle that for the rest of us. But I love this book. I think it really gets to the underpinnings of what reasoning and sense-making in mathematics is all about. And then, of course, most of us are dealing with the Common Core. I have a new computer. It doesn't like my little clicker, so I'm doing it by hand. So from Principles and Standards for School Mathematics, we have the NCTM process standards. And if your teachers have a little bit of a hard time trying to decipher what the standards for mathematical practice are all about, I really recommend you go back and reread these and study these, because they are the underpinnings of the standards for mathematical practice. How do we look at connections, communication, problem solving, reasoning and proof, and representations, and how do we do that in our classroom? The other thing I think that's really important, and I've been giving a lot of thought to this, are from Adding It Up, the book I just mentioned that was published in 2001, what they call their strands of mathematical proficiency. And I think I just lost, oh, somebody's trying to pair with me. I don't know about that. I don't want to pair with you right now, and it just, thank you very much. I don't know who's, there we go, we're back. Isn't technology wonderful? I've really been giving a lot of thought to these. Some of these are no-brainers. Others are things I think that can really help us make that connection to what makes effective instruction. I want to save the first one for last. I think the whole notion of strategic competence, conceptual understanding, and a productive disposition is something that's a little bit new. Productive disposition is just making kids feel good about how they perform in mathematics. To see that mathematics is useful and worthwhile, somebody is still trying to pair with me. So we'll wait and see if the miracle happens. This is really strange. All right, and then procedural fluency. I wrote a president's message on procedural fluency not too long ago. It doesn't mean do it right and do it faster. I want to go back to adaptive reasoning, because I've been thinking long and hard about this one. So those of us that are in the classroom, we teach kids, we think they know it, and it comes time to take a test, whether it's your state test or a standardized test, and all of a sudden the stuff that we thought they really knew, they don't know anymore. And I'm not convinced that they don't know it. What I'm convinced of is they don't know how to apply it in a situation that looks very different than the situation in which they learned it. And that is the adaptive reasoning part. How do we teach the mathematics in a way that the kids aren't limited to, all right, so I taught 5th grade, and that was the year of fractions. Still is somewhat. And so we had manipulatives. We had more manipulatives than we knew what to do with. And I remember the kids were adding and subtracting before we did anything else. They worked with fraction circles. And all of a sudden I gave them a subtraction problem that was different than just, you know what you started with and you take away part. And the kids didn't know what to do, and all of a sudden it clicked on me that they knew what I had taught them how to do and what they had experienced very well, but they hadn't had all of the experiences to adapt their understanding to other situations. All right, so that's our background. And then of course we have the Common Core mathematical practices. I'm not going to spend a lot of time on those. I think I know them by heart, but I see them as clumped somewhat. I think the first 3 are really strongly interrelated. I don't believe that you can make sense of problems and persevere in solving them if you cannot reason abstractly and quantitatively, and if you cannot construct viable arguments and critique the reasoning of others. I also believe that modeling with mathematics involves using appropriate tools strategically and knowing that vocabulary. And then finally, the 2 that I struggle with the most, because I think they're so closely related, is that idea of looking for and making use of structure. And again, as somebody who spent a lot of time in the classroom and spent a lot of time focusing on mathematics, at the particular grade levels I'm looking at, the whole idea of looking at the structure of mathematics is really a change of a mindset for me. And then that whole idea of expressing regularity and repeated reasoning. So let's get to the practices. What are these instructional practices? Number 1, I believe that you should never say anything a kid can say. So when I hear teachers talk to me about, and I'm going to be brutally, I had a friend who said never say that teachers do something they shouldn't do. I think we're still so focused on showing and telling kids how to do it. And that is the way that many of us operate, that we really have to think differently. And I love this idea of never say anything a kid can say. I have an article from Mathematics Teaching in the Middle School, which I believe is from April 2000. I'll tell you a little secret. If you Google it, you can find it. It's illegal, but it's all over the internet. We still use this article with every teacher we work with from K through 12. And I see a couple of heads nodding, so if you haven't read this article, if you don't get anything else out of this session, look up this article. It is awesome. And the title says it all. How often do you go up to a kid when they don't understand and you pull the pencil out of their hand and start showing them what to do? Even when I'm working with teachers, I have to walk around with my hands behind my back because when they aren't sure what to do, I am still so tempted to pull that pencil out of their hand and start showing them. We've got to stop showing and telling kids what to do. We've got to give them the opportunities to figure these things out and to think about them. That means we have to really appreciate the power of productive struggle. That sometimes letting kids struggle with a concept, sometimes struggling with a concept ourselves, especially as we're looking at Common Core, is really critical. It also means that we can't expect ourselves to change 100% in a year. So one of the things the author of the article talks about is promise yourself you'll do 10% a year. I'll change 10% of my practice every year. I'm not going to pull a kid's pencil out of his hand for this entire year. I'm going to stop and think about what questions should I ask this child now before I tell him what to do. Practice number 2, ask clarifying questions. This is something my last 5 years in the classroom that I gave myself permission to really think about. When a kid said, I don't understand what to do, or my favorite is, I don't get what they want me to do. And I finally said, who are they? I don't get what they want me to do. Do your kids ever say to you, I don't get what they want me to do? It's like we have these mysterious textbook authors living up in the sky and they, make kids' lives miserable. So I think we can really ask kids some questions to help them figure it out. One is questions that I would ask to individuals or groups of students who are working on something that are stuck as they're in the working process. And one would be, what do you know so far? So getting kids to interpret what information is given there in the problem. What do you know so far? And then the next question might be, what are you wondering about? What is it that's causing you some confusion? It's really hard, by the way, to figure out what's causing you confusion. So the first time you ask kids that, they might give you a really blank stare. But what are you wondering about as far as the problem is concerned? And then asking them to go back and review, what have you tried so far? Can you draw a picture of what's going on in the problem or the task? Can you try this with simpler numbers? And those of you that are trying to take pictures of this, I remind you that this will all be online, so you'll be able to download the whole thing. I like this one because this one links directly with a standard of mathematical practice. Can you try this with simpler numbers? I think that's one of the most powerful problem-solving strategies we have. Can you figure out how to do this with easier numbers, and can that help you to do it with a more complex situation? What tools might you use to help you? Is your answer reasonable, and how do you know? So those of you that have heard me talk before, this is one of my favorite stories. When I was promoted with my 5th graders to 6th grade, and knowing full well that my kids in 5th grade had had lots of experience with fractions, I knew when it came time to review fractions that my kids were going to know that. So I put on the board 1/2 plus 2/3. And for the first time, the kids saw it vertically. This was quite a few years ago. And so I said, what's 1/2 plus 2/3? Can you guess what answer I got? 3/5. And I looked at them all and I said, who was your math teacher last year? They said, you were. And I said, well, obviously, she didn't know what she was doing. It dawned on me that the whole notion of having kids taking that time to decide whether or not their answer was reasonable was something I hadn't done. So each kid had their own set of fraction circles. We all had fraction bars. We had all the models there. I hadn't stopped to ask them, why, when I add 1/2 plus 2/3, is 3/5 not a reasonable answer? Now, with all the undergrad and graduate classes I'd taken in mathematics, I still made that mistake. It really changed the way that I taught and thought about doing mathematics with kids. There are also clarifying questions that you can ask when you bring the kids back together again to talk about their thinking. By the way, my classroom was always kids working together in groups, almost to the point where I had parents come in and said, well, they work together in groups all the time, except when it comes to take the test, they work by themselves. So that was I had to think about that a whole lot. But it was important to bring kids back together again to share their thinking and share their strategies. So the kinds of questions that I would ask is, who wants to share their thinking? I also had been walking around to watch what groups and kids were doing, so I knew the order in which I wanted to call on kids. And at first there was a great deal of reluctance because kids weren't willing to put their thinking on the line in front of other students for fear of being wrong or teased. But as we grew that protective culture in our classroom, kids were much more willing to share their ideas. And oftentimes when I would say to kids, how did you get that? They would say, I just knew. So a wonderful question that I found in some article was, instead of I just knew, what was the first thing your eyes saw or your brain did? So kids could actually back up. Sometimes bright kids will say, I just knew. And I think it's just as important for those kids to be able to backtrack and really think about where did that idea come from as it is for kids who struggle. So what was the first thing your eyes saw or your brain did? And I love this one. Convince me. You know, if this is the way you did it, convince me you're right. How did you figure that out? Billy, can you tell me where that 5 came from? So as kids are explaining, ask them where different parts came from. How many people did it the same way as Billy? So can I tell if my strategy was the same as the way Billy solved the problem? Notice that at this point, the teacher has not gotten involved with how to do the problem. What's the right way to do it? And this was a big leap for me as a classroom teacher, but I found that if I showed them, then my way became the right way and the only way. And I shut down a lot of powerful thinking on the parts of kids. Who has another strategy? So after they show their strategy, how is your strategy the same as the one we just saw, and how is it different? I had the opportunity to stop in the RTI pre-session yesterday, and they had all of these posters hanging on the wall, and they were just taking apart 3-digit plus 3-digit addition problems, and all of the strategies on the wall. I wanted to grab my iPhone and start taking pictures of them. They were just awesome. That's the kind of thinking we need to give kids the opportunity to do, and our questioning can support that. And I love this one. And this might be a little tougher for primary level kids, but upper elementary and middle school kids, we ought to be asking them, does your strategy always work? And can you find a time when it doesn't work? Or open that up to the class. Construct viable arguments and critique the reasoning of others. And we also need to avoid, and boy, I fall into this all the time. I even fall into it now when I'm working with teachers. A question that can be answered by yes or no, you got a 50-50 chance of getting that one right, don't you? And asking, do you understand? Do you understand? Like, some kid's going to say no. How does a kid know whether or not they really understand? That's our job as teachers. There is a wonderful card that was put out by PBS Mathline years ago, and I struggle every time I try to find it online. Here's the website. I found it today before I came down. I thought I've got to give them this card. And it's a two-sided card with all kinds of different questions. Some of the ones I shared with you. You can print it out. And our in-services, we actually duplicate it and give it to teachers. And some of the teachers have actually used it as a bookmark in their textbook. So they have it in front of them and can practice, what kind of questions should I ask? Give yourself permission to stop and think, what question should I ask this kid right now? What would be the best thing, the most helpful thing that I can ask this child right now? And again, if you didn't get that down, it'll be online. So practice number 3, I alluded to a little bit, it's focus on strategic thinking. And when Principles and Standards came out, maybe even the original standards, a lot of the textbooks that came out had a first chapter on problem-solving strategies. They were never mentioned again in the back of the book, but the first chapter was on problem-solving strategies. And somehow we have gone from overkill to we don't hear a whole lot about them anymore. But I still believe that these problem-solving strategies are something that we need to give kids explicit experience with. Some of them are a little bit inherent. You know, we tell kids draw a picture or diagram. Did you draw a picture? Can you guess and check? Kids like that one. But I do believe, and this is just something that I did for another project I was working on, but I think if we could start as early as 3rd grade, if not before then, and teach these problem-solving strategies along with rich tasks that exemplify the content standards and give kids that explicit vocabulary about what strategy do you think you can use to solve a problem, that would be really helpful to students. I did this for many years with my kids, and I still remember after the first year, and my kids hated, they called them, this was back in the 70s, they called them the problems of the week because they said they felt like prisoners of war when they did them. But at the end of the year, I still remember a group of 3 girls coming up to my desk saying, Miss Gojak, how come you saved all the easy problems for the end of the year? Somebody's still trying to pair with me. I'm still not going to. And I just had a giggle because I hadn't saved the easy problems for the end of the year. Actually, these were quite challenging problems, and the kids had really internalized those problem-solving strategies. The other parts of strategic thinking that I think are really important, and we tend to forget them because they're not always in our books, or they're not very explicit in our books, is this idea of multiple representations. And this is particularly true for kids who struggle in math. And that is that we really need to go back to our friend Piaget and think about what he taught us. And that is for kids who struggle, we really need to be cognizant of starting on the concrete level. And whether you're teaching middle school in integers, or whether I'm teaching elementary school in early ideas of multiplication or addition and subtraction, that idea of getting kids materials to work with, especially those kids who are not oral learners, who are visual learners, who are kinesthetic learners, they need to see that. I say that because I think I was more of a visual learner than I actually realized. I was also a good memorizer, and I'm not sure that that served me very well in the long run. So after the kids have had many concrete experiences, then we move to the pictorial or the semi-concrete. And then we have to think about this actually my graduate professor added this extra one in, and I like it. The semi-abstract. I don't believe that number lines are totally abstract, but I don't believe that they're totally pictorial or concrete either. So I think about them as semi-abstract, and the reason I bring that up is number lines are really big in the Common Core. And then finally getting to the abstract. And those of you who teach middle school, this is just as important in the middle school as it is in the early grades. So I think we have to go back and look for resources that will help us. And here's a simple example. We could start with the concrete, and because I don't have concrete materials here, I'm actually working on the pictorial. When I might be introducing multiplication and talk about the notion of 3 groups of 4. And if kids don't have a lot of opportunities to see 3 groups of 4, make 3 groups of 4, and it could be 3 groups of -4, by the way, before we just tell them to go home and memorize their facts, that's where the kids who struggle really get in trouble. And from that concrete, we move to the pictorial. If those of you who are not familiar with the game Circles and Stars, Google it. So that's where we're moving from the concrete to now we're playing a game. One number tells us how many circles, one number tells us how many stars go in a circle, and we start to connect what 3 times 4 looks like from that concrete to the abstract, and we do it in a game environment, by the way. And then we can also start to think about arrays. So I would also think about arrays and the number line as a semi-abstract representation. Not all children, by the way, need to go through every one of these steps, but many of our kids who really struggle do. And too often we skip them and we move them right to the go home and memorize your 3 times 4s tonight or your times 4s tonight, and they can't do that. And again, that's that adaptive reasoning. They might have worked with 3 groups of 4 in the classroom, but they have not had enough opportunity to really go back and think about what does that mean for other multiplication facts. And finally, again, I chose a simple example, but the whole notion of when I'm talking about 3 times 4, that really means 3 groups of 4. And what's really important here, and I'll get to it in just a second, is the notion that if kids don't understand this, when we get to division facts, we are in trouble. Because the connection between multiplication and division facts is critical. So that when I have 12 divided by 3, I'm asking 12 divided by 4. I always have to think about this. How many groups of 4 can I make out of 12? And I think how many groups of 4 gives me a mental image, that visual image, much more than how many 4s are in 12, by the way. So language is really important here. Okay, practice 4. I think we really need to give kids opportunities to estimate, and we need to be explicit, and I don't think we need to teach them rounding rules. Thank you. Thank you. Because rounding rules are part of this mysterious bag of tricks that we've taught kids. And I think oftentimes when they go into testing situations, they're trying to reach into that bag of tricks and they're not sure which trick to use right now, especially if the trick looks different. So here's an example for those of you who might be upper elementary, middle school. I love this, and I've used it before, so if it's repetitious, I'm sorry, but it's just one of my favorite examples. And you can use it with other number systems. Tell me everything you know, and I'm going to give you some time to talk to your neighbor about this. Tell me everything you know about the answer to this problem. You don't have a calculator, and you have not learned how to do this. So you have not learned how to count the decimal places and put that many in your answer. What do you know about this answer? You've never learned anything about multiplying decimals, but you do know what multiplying by whole numbers means. What can you use to tell me what you know about the answer to this? Tell me what you know. Talk to your neighbor about it a little bit. What do you know about the answer to this problem? Okay, who wants to shout out a thought? What do you know?
Less than 1.
It's going to be less than 1? How do you know it's going to be less than 1? So if I'm multiplying by a number that's less than 1, does that tell me the answer is going to be less than 1? But it's going to be less than 16, isn't it? So I know the answer is less than 16. What else do you know about that answer? Yes? Okay. That, she said, so 0.05, which by the way, if I can bring people along, sometimes the teachers I work with think I'm a little bit crazy. Please read that as 500ths and not 0.05. And the reason is that 0.05, although it's easier to read it that way, doesn't have meaning to kids. You know it's 500ths, I know it's 500ths, but if I can get a kid to read that as 500ths, they're starting to think of that as part of a whole. All right, so I know that 500ths is the same thing as 5 cents. If I put a dollar sign in front of that, so I can think about that as 16 nickels. That, my friends, is adaptive reasoning. That's a kid saying, I see something familiar there, and I can use what I know to figure out what I don't know. So go ahead. What do you know about 16 nickels?
I would count by 5, 16.
Okay. And then I'd have to think about how much would that be in cents, because now I'm working in cents. Does that help me with the decimal place value? It sure does. So if I count by 5 16 times, and I realize I'm talking cents, I can then figure out where the decimal point's going to go. Anybody else? I feel like I'm on a safari here. I can't see with the lights on my face. Anybody else? All right, let's do another one then. That's great. How about this one? Tell me everything you know about the solution, or tell me anything you know about the solution to this problem. Yes?
Well, I know that 9,500 is almost 1, so my answer is going to be practically the same number.
Okay, she said, I know that 9,500ths is almost 1, so my answer is going to be practically the same as 39 and 5/10.
And 39 and 5/10 is almost 40.
It's almost 40. So my answer is going to be around 40. Now I have another question. This is what I would do with my students. In general, not necessarily you. You had really good thoughts there. Is my answer going to be more than 39 and 5/10 or 40? Or is it going to be less than 39 and 5/10? It's going to be less. Why? Because I'm multiplying it by a number that's less than 1. Now I'm going over this much more quickly than I did with my 6th graders. But boy, did we have rich conversations, and I had not taught them the rule to count up the decimal places. However, we did write down what they knew. We took very careful notes on what they knew. This was before smart boards and Promethean boards, but we did it on chart paper, and we hung it there, and then we tried to develop what's going on when I multiply fractions, and can it help me figure out where the decimal point goes. How about this one? I could talk about these all day, by the way. How about this one? What do you know about the answer here? Watch carefully. I changed the sign on you. Can you give me a rough estimate? Oh, you're all of a sudden you can talk to your neighbor, it's fine. Somebody give me a shout out. It's going to be 800 and some? Around 800? How do you know that? What's that question really asking? It's going to be 800 something. So how do you know that? Somebody who hasn't had a turn yet. Yes, go ahead. This is the disadvantage of sitting in the front of the room.
It's kind of like asking how many halves.
How many pieces that are half can I make out of 400 and some? I mean, just round them and think about what are the values of these numbers. And if I have 400 and a little bit more, and the size of my piece is going to be a little bit more than half, I can start to think my answer should be around 800. Boy, would I be thrilled if kids came to me in 7th grade having that kind of number sense. Instead of picking rules, everybody know what I'm doing here? Because that's the way I learned it. So really getting to think about the value of the numbers and developing number sense on how does that work. All right, here's my last one. What can you tell me about the answer to that problem? Somebody brave. It's going to be a little less than 82. How do you know it's going to be a little less than 82?
Because if I'm taking out each time one and a little bit, I won't have enough to take it 82. So I was only taking in groups of one, I can get 82. That's like that.
Your groups are a little bigger than one, so you're going to be able to make a little less than 82 groups. It's that notion of understanding the power of one. If I understand what happens when I divide by one, if I'm dividing by more than one, I'm going to have less. If I'm dividing by less than one, I'm going to have a little bit more. That's a little bit counterintuitive for a 5th or a 6th grader. And you can make up your own. I start with simpler ones. I gave you ones that were a little bit trickier because you're a little bit smarter than a 6th grader. But this is really powerful in a 6th grade class. All right, practice 5. Make connections explicit. So we have worked with our 3rd graders and our 4th graders, and they really understand with whole numbers that 9 divided by 3 means how many groups of 3 can I make out of 9? Or I want to make 3 groups out of 9 things, how many go in a group? And then what happens when we give them an example like this? All of a sudden it becomes this mystery rule, invert and multiply. Ours is not to reason why, just invert and multiply. And I have a funny story because I once taught the kids, and the way I'm about to explain to you, or we once worked together. I shouldn't say I taught, because I really try to stay away from never saying anything a kid can say. I try to set up the opportunity for them to make the connections and draw the conclusions. So we were working on this, and then I sent them off to study hall to do a few more examples, probably before they were ready. In our study hall, we had a study hall at the end of every school day, and the English teacher happened to be, we were an unusual school because we departmentalized starting in 4th grade. It was awesome, by the way. And the English teacher was in charge of study hall. And the kids came back the next day, and they had the wrong answer on every problem. And I went, what did you do? And they said, we weren't sure what to do, so Mr. Lowe showed us how to do it, and he told us we could just flip a number and multiply. Unfortunately, Mr. Lowe taught them to flip the wrong number. So you don't know how badly I wanted to say, tell Mr. Lowe I don't mess with his English lessons, leave my math lessons alone. But what I want to do is I want kids to see the connection between whole numbers and fractions, what you just did with decimals. Why can't that mean to kids, how many groups that are 3/10 of 3/10, size of 3/10, can I make if I start with 9/10? And what happened when I taught my 6th graders this, I think this is a really hard concept for 5th graders. By the way, I also think it's a really hard concept for 6th graders, so I'm waiting to see what happens in the way that the Common Core talks about this. But what's interesting to me is the kids came up with a really interesting explanation of what the denominator meant. They said, Ms. Gojak, the denominator is like describing this, it's just describing the piece. It has nothing to do with how many we have. So this is no different than saying I have 9 apples and I want to make groups of 3 apples. I just thought it was just like these kids were 6th graders. I was at a graduate school and I had not thought about it in the same way they did. That the denominator had nothing to do with the count, it was just describing the size of the piece. We had talked about that with addition and subtraction, by the way. But I hadn't really thought about that in the context of division. The other thing that's really cool about this is even if your denominators are different, as long as I can get all the pieces the same, I can do the division. That means that when kids have to find a common denominator in addition, and kids have to find a common denominator in subtraction, doesn't it help them a little bit to find a common denominator in division? We're not teaching them a whole new way to think about this. Now, if you're teaching in the 7th and 8th grade, at some point the kids need to understand the multiplicative inverse. But I think when they're first learning to do this is 5th and 6th, and maybe even at the beginning of 7th grade for those kids that struggle. If we can make those connections to what happened with whole numbers, instead of teaching them a whole new bag of tricks, that we are really giving them, the other thing that happens here, by the way, is that, and this was my own experience as a student, I knew what was going on when I multiplied. I knew how to multiply fractions. I've told my kids that I could go teach 3rd graders who know their multiplication facts how to multiply fractions. Doesn't mean they're going to understand what's going on. So even if I can teach them how, and they remember flip and multiply, give them some problems to solve and have them figure out whether they use with fractions, and have them figure out whether they use multiplication or divisions. They struggle terribly because they have no anchor to really think about what's going on. So I hope we can watch for more of these kinds of things and make those connections as we're thinking about how do we teach these things, especially for kids. I'm a little bit worried about some of the stuff in the Common Core around fractions, and I think there are some really powerful big ideas there, but we as teachers have to look at what are some of the foundational things that are going to lead to those big ideas. And that's intentional, by the way. That doesn't mean the Common Core authors didn't know what they were doing. It means that we have to think a little bit harder about how we do this. But I think it has the potential for being really powerful. So we'll see how it all unfolds. Okay, practice 6. And I stole this one from Steve Leinwand. Incorporate daily review into lessons. And I'm going to take a little bit of extra time on this one because I have discovered something called number talks. How many of you are familiar with number talks? Oh, yay, then I can go fast. But if you're not, I have 2 websites. One is there are some really good videos of number talks on insidemathematics.org. And if you're not familiar with that website, it is awesome. And Google or search for number talks on there, but you'll find all kinds of other really good video examples on that website. The other is Ruth Parker's website. Ruth is the first person I ever heard talk about number talks. And it is mathsperspectives.com, and you can get more information on number talks from Ruth. But a number talk, and if you didn't have time to write these down, just download. I'm sorry to keep saying this, but don't worry about writing it all down. You'll get it. I got my teachers to do number talks, and what was powerful about getting them to do number talks was they didn't have to learn anything new to do them. They could do them with stuff they were already comfortable with. So what happened was, in the district I was working with, they were on a pacing chart. Don't you just love pacing charts? We move on whether the kids get it or not. Now, I understand some reason for pacing charts, but we still have to think about what kids get. So I'm working on multiplication in the 4th grade, and my kids still can't add with regrouping. So a number talk gives me that opportunity for a short amount of time every day to go back and review and reteach and have kids develop an understanding of addition with regrouping or whatever topic I choose. So it's a short, ongoing daily routine that provides students with meaningful and ongoing practice with computation. It also helps kids to develop computational fluency because the expectation is that they use number relationships and the structure of numbers, kind of standard number 7, I believe, to add, subtract, multiply, and divide. Could be fractions, could be integers, could be whole numbers, and I've seen kindergartners do this just with developing number sense. So number talks develop number sense, they develop fluency, they encourage strategic thinking, and they help kids to use representations that make sense to them. This is the way it works. The teacher presents a task. I'm going to do one shortly. We won't do the actual number talk, but I'll show you one. The students have time to mentally figure out the answer. When they get the answer, they give the teacher a thumbs up. This is kind of cool because I'm the smartest kid in the class, and I'm not sticking my hand in somebody else's face who's trying to think. You know, those kids who are always labeled as the smartest kid in the class. They probably can't do PE very well, but they know how to show their muscle in math class. That's okay too. Then the students share their answers. The teacher records them on the board, and then the focus is not on the answer. It's one of the things I love about this. Then the students share their thinking. So kids will explain what they were thinking. In the upper grades, they can actually come up and write on the board. In the lower grades, the teacher records it. As the kids are sharing different strategies that they use, kids might say, oh, my answer was wrong, could you cross it off? And the teacher's just, again, no value judgment about right or wrong answers. Okay, you think your answer's wrong, we'll get rid of it. So they're sharing their thinking and they're sharing different strategies. And then the class, they share their answers, they share their thinking. And then the class agrees, yeah, we think 28 is the right answer. And then we give the kids another example. So you want to prepare and have several examples ready that are related and that build. And you have to know that if the kids can't do the first example, I go this way. And if they can, I go that way. So you're kind of adapting what you're going to do with the kids based on their level of understanding. I went in and did this with a group of third graders in Connecticut before the regional there. I had no idea what to expect. I just asked the teacher if I could work with the kids for 10 minutes. They blew the teacher away. She sat at her desk with the biggest grin on her face because she could not believe the rich conversation her kids were having. What is the teacher doing? It's really important for the kids to have a safe environment during a number talk, during any time, that it's okay to make a mistake. Too many kids enter school thinking the goal in mathematics is to get the right answer, and once I've got it, my thinking can stop. I'm done. Teacher's happy, I'm happy, I got a good grade, I'm done. So the teacher needs to provide a safe environment so it's okay to make a mistake. The teacher has to prepare what problems they're going to use in a number talk. The teacher selects problems that begin with ones that kids intentionally, first of all, that highlight a particular math concept, and that will focus on valuing everybody's thinking. And focus the shift of thinking from my doing it, see what I'm doing, kids, to what do you think about it? The teacher does the recording, especially with young children. This is important. Have you ever sent a first grader to the board to share their thinking? I've been in a first grade class. I did not spend most of my teaching career in a first grade class. They want to tell you everything they know about any topic under the sun. So, and they're so cute, so it's really hard for me to turn them off. So the teacher records so the kids aren't going off in a wrong direction. The teacher asks questions that clarify the kids' thinking and then might restate, what did you just say? And maybe, it's hard to say it, so the teacher might say it in a way that's a little clearer. And then there's an absolute part of formative assessment that goes on in a number talk. I know who's getting this idea and I know who's still struggling. I don't have to give the kids a piece of paper and pencil to figure that out. All right, so this might be an example of what I might do with 5th or 6th graders in a number talk. And you know what happens. You teach this and they kind of get it, and then 2 weeks later you put it on the board and what do they say? 3 3/5. So this might be an example, and it might not be the one I start with, but I might have a series of subtraction with mixed numbers and have kids work through this, draw diagrams, and again, I can see where their thinking is. A number talk, by the way, is only 5 to 10 minutes a day, so you're not trying to kill the world with a number talk. But you do it every day, so for 5 minutes every day. And those of you that teach in a self-contained classroom, I still remember that 10 minutes I would have before the kids went to gym. It's a great time to have a number talk. 10 minutes before lunch, great time to have a number talk. I have a friend that taught in a really high-needs school with kids, it was an elementary school, but still kids that had a pretty tough reputation. And she called them her little hellions with love in her heart. And I asked her to do, I don't have it on this slide, but she said, every day, the calmest part of my day with my little hellions was our number talk. And if the end of the day came, and she always shook their hands as they left, and then I hope she sanitized her hands. But she said if she didn't do number talks, the kids would remind her, Mrs. Mano, we didn't do a number talk today. And she saw a real, not an incredible difference, but they saw a real improvement on those kids' achievement tests. And she really attributes that to doing number talks with her kids. Okay, practice 7, use rich tasks. I did not give anybody credit for this. I don't know if you can see this from the back of the room. It's not very exciting. It's a sheet of addition problems, addition of fractions. So, a thing that a kid in 4th or 5th grade typically loves to go home and do for homework, and then you wonder why they come in and they didn't do their homework. This, by the way, can be a rich task. I can do the same thing with this task that I did with the decimal task by saying, for example, I can't even read the first one, 2/3 plus 1/7. Tell me what you know about the answer. Is it going to be close to 0? Is it going to be close to half? Is it going to be close to a whole? Is it going to be more than a whole? Again, give those kids number sense. But to give kids 20 problems to go home and do for homework, it's just not, it's not developing any number sense. And if they do know how to do it, I'm not against drill and practice. They don't need 20 of them to drill and practice on. Why not give them something like this? By the way, I've seen this activity done in all kinds of contexts, so think about it. I give the kids 6 cards, and I say use 4 of the cards below to make 2 fractions whose sum is close to 1. Do you want to know how much mental estimation kids have to do and how much number sense they have to do to really think about 2 fractions when they come up to 2? Is that going to be greater than 1? Can you find a way to do it that would be less than 1? Can you find a way to do it that's going to be closest to 2? Can you find a way to do it that's going to be closest to a half? So there's just all kinds of, now don't do those all at one time, by the way, but you can take this activity, I can take this same activity and say, find 2 two-digit numbers, one is negative and one is positive, where the answer is closest to 0. Find 2 two-digit numbers where I add them together and the answer is closest to 100. So you can take this simple activity, and the amount of practice that kids do is very close, if not more than the amount of, and they're developing number sense. They're developing number sense. Here's another one, I love this. By the way, this is my dog, Pumpkin Pie. I had to get her in here somehow. I miss her terribly. She's my baby. So I want to build a puppy pen for Pumpkin, and I have 16 feet of fencing. What are all of the different puppy pens I can build for Pumpkin Pie? I feel like I'm at an English conference here. And don't use any fractions or decimals, by the way. And if you're teaching 5th or 6th grade, you might say, I can use halves, or I can use thirds. But talk about the idea of teaching kids perimeter without saying, add the length, double the length, and add double the, give the kids a chance. They can figure out what this is about. And then you can bring that to closure and help them to talk about what they've just done. So Pumpkin got in the presentation. Practice 8. And this one is so important as we start to think about the assessments from the Common Core, but I also believe it's important even for the state assessments we had. I'm from Ohio, in Ohio before Common Core. That we ought to be giving kids warm-up activities at the beginning of a period. And by the way, a number talk is a warm-up activity. Might be on a different topic. First of all, it tells us about what the kids know or don't know about what we're going to teach. It could be written, it could be oral, it could be a game. My job as a teacher is to walk around and listen to the conversations and probably take some notes. So I taught 5 classes of mathematics a day. And I had at least 20 kids in a class. So that means at the end of the day I had 100 kids. And my goal at the end of the day was always to sit down. I tried every organizational strategy. You know, I had a file card for each kid. I had Post-it notes. I finally just had a simple sheet for every class in a clipboard with a word table and space to write about. Ruth needs more help with this. Make sure you do that. And I listened to kids' questions and answers very carefully. So again, listening to student responses and analyzing student work during class. As I'm walking around and really eavesdropping on student conversations. Doing a quick write. Tell me what you know about this. Here's a quick one. Write it down and show me. Our coaches in the district that I've been working with have really been working with the teachers on developing exit slips. So I have some sense when the kids leave by 1 or 2 examples to know, did they get what we were doing today or not? And interestingly enough, sometimes they use today's exit slip as tomorrow's warm-up. So did they remember from today to tomorrow? Did they remember tomorrow what we did today? There's also an excellent NCTM research brief on formative assessment. So I wanted to also let you know that those things are up there. And if you Google formative assessment, by the way, if you Google anything, you're going to find some good things and you're going to find some things that are, quite frankly, garbage. And you're going to have to really start to know, how do I differentiate between the two? So just because it's on Google doesn't mean it's good. When I was in the classroom, interestingly enough, and again we were self-contained, I had a wonderful English teacher in the room next to me. And every week on Monday she would come in and write the schedule for the whole week. And our reading in English was taught through children's literature. One of the books the kids read was The Phantom Toll Booth, which was one of my favorites. We did a whole math project around, talk about integrating, around the Phantom Toll Booth. But the kids would come to me and say, Miss Gojak, Miss Smith, lets us know what the homework is for the whole week, so if we want to work ahead and read ahead, we can. Can't you do that for math? And my answer was no. And they would go, why not? And I would say, because what you do today in class determines what I'm going to do tomorrow in class. And I think that that's the kind of formative assessment. We don't need multiple choice tests every other week. We don't need anything really, really formal. Formal is okay. But we take so much time, so much instructional time with assessment. I'm really worried about that. I am worried about the amount of time that the assessments are going to take for the Common Core. I'm worried about the amount of time, even in the district I'm working with, that they do with, I can't remember what it's called, but some computer-based assessment thing that they do every other week, and then they do their formative assessments. I'm really worried about the instructional time that that takes away from teachers. And that the assessments can drive instruction, but I think they can drive them in a much more powerful way. And finally, I think, so those are my 8 practices. But I think that we need, as we work to improve our teaching practice, we have to remember, it's not just about teaching better mathematics. It's really about teaching mathematics better. And I think that that's the thing we all have to work on together. And I hope that that's what you're going to get out of the conference. I know I'm finished a little bit early. I'm happy to entertain questions. And I just want to thank you for your attention. So if you have questions, I'll be up here. I will get the slides up as soon as possible, and thank you for coming.